Hello everyone. Welcome to the third session of Coffee and Code Club. Now this is the first time that we're streaming Coffee and Code, so it's a bit of an experiment, but we hope to keep this going in the future as well to make it more accessible to everyone. If you experience any technical issues or have any comments or suggestions, then feel free to contact me afterwards so that we can fix it for coming sessions. So today I am very happy to present Steinar Sturlaugsson, who is a systems developer at the Snip and Seek facility in Uppsala. If you have any questions, feel free to post them in the Zoom chat if you're joining us here on Zoom, or in the comment section on YouTube. And we'll make sure to post these questions to Steinar either during or after the presentation. So I hope you're all sitting comfortably and have brought your favorite brew with you. And now let's welcome Steinar.
Yeah, thank you. I'm going to talk a little bit about Python 3, and I'm going to ask, was it worth the wait? Because we've all been waiting quite a bit to use it. Maybe not everyone, but the community in general. Oh, sorry. So I'm also going to ask, why did we wait at all? And I'm also going to add some context to Python. Try to do that. Yeah. Presented by me, and before we get to this, I'm just gonna tell you a little bit about me. Like Sarah said, I'm a developer and an architect at SciLifeLab Uppsala, the Snip and Seek platform. I worked mostly with Python and C#. For the longest time, I used mostly C# actually, Python a little bit here and there, but for many years I've been using Python exclusively. Or just about. I love this language, but I do sometimes miss static typing, I have to say, and that relates a little bit to our story today. I have worked in different industries, health and science, banking and finances, and actually video games also, but sadly only the boring part of that. So I was working in a company called CCP, which is the maker of EVE Online, which is a very large online role-playing game. And they are perhaps the heaviest user of Python in the gaming industry. So the game server is written in Python. Then, of course, they have C++ code too and all that, but Python is a huge part of that game. And they have been using it since the early 2000s. And as a side note, I do doubt that they will ever upgrade. So my department, the boring department, I was working in external systems, the web systems and various systems that need to run also in a gaming company. We actually used C# almost exclusively, but we upgraded constantly. So there's a little bit of a, there's an obvious difference in these two stories. We got C#, we're constantly upgrading Python. For some reason, they're probably never gonna upgrade. So before I get into this question of if this was worth the wait, I'm just gonna give this context I was talking about. There's a little bit of a history lesson about Python. So year 0, 1999, a Dutch guy named Guido had a problem. So he said that he realized that the development of system administration utilities in C was taking too long, which I think probably most of us are gonna understand. He was familiar with Perl 3, but he thought that was even more tied to Unix than the Bourne shell. So he didn't really solve the problems he wanted to solve. So obviously he wanted to do something else than the Bourne shell. And didn't like the Perl syntax. His tastes were strongly influenced by Algol 60, Pascal, Algol 68, ABC. 2 years later, he releases 090 to alt sources. And in the README, we could read exactly this focus on clear syntax. This is Python, an extensible interpreted programming language that combines remarkable power with very clear syntax. That's a true statement today, at least. So year 11, Python 1.6.0 is shipped. I want to mention that because in the release notes, one could read, we've added a new fundamental data type, the Unicode string. So the meaning here is that before this, Python did not support Unicode, and they added a new data type, as most of us probably know, which is the Unicode data type, rather than just replacing the string with the Unicode data type. Nice thought, I thought, but personally, I would have preferred if they would have just gone 100% Unicode, because that was what I knew from Java, which I had used quite, at least somewhat before this and studied in school and so on. So I remember that Java actually had 100% Unicode from 95 when the specification was written. I believe it was already in the first specification of Java that it should be Unicode. All strings are Unicode. So perhaps the Python core team would have done something about it if they knew where they were headed, and that is world domination, as can be seen by this graph. At least if it's still going like this, it's probably the most popular language in the world today. But I actually only have numbers from 2018. I didn't bother to upgrade this from my previous version of the slides. Sorry about that. But we all know that this is a very, very popular language today. So this same year, Python 2.0 is shipped, and we're gonna jump forward in time now. And things happen with Python during this time, but we're gonna go over to 2008 when a release that we probably, many of us know, and maybe this is the first one some of you used. This is the first one I used, 2.6 was released. And then the question is like, okay, 2.6 was released, but what came next? And I think many would guess that it's sequentially just going to 2.7 then, right? But that same year, we get the protagonist of the story, Python 3. So this is 12 years ago. But 2 years later, we get the antagonist, Python 2.7. So the version of Python that we've all been using, probably primarily for various reasons. So the question was then Python 2 versus Python 3, like what were they adding? Like why make a switch? Yeah, okay, I had an animation here. So let's just ask Python org. So Python 2.x, they said this in 2010. Python 2.x is the status quo. Python 3.x is the shiny new thing. So 2 years later, they say Python 2.x is still the status quo. But Python 3.x is the present and the future of the language. So they're strongly indicating that everyone should upgrade now. 2014, they say Python 2.x is legacy. Python 3.x is still the present and the future of the language. So 2014, we had a legacy product according to the main developers of the language, or the core developers of the language. 6 years later, many of us are still using 2.7, and I am doing that too, just to be very clear about that. We are still using it with a lot of backports and helpers, but at the heart of it, we are using 2.7. And there are many things from 3 that we don't have. So why are we doing this? The answer is bringing changes. So I mentioned that CCP are never going to upgrade their huge code base, and that is because of these breaking changes. For a business like that, it's probably going to hurt, at least in the short term, and maybe not give them that much in return. So you could even read this right from the what's new in Python 2.7 notes on python.org. While there is a large common subset between 2.7 and 3, some other changes, notably those associated with Unicode handling, may require careful consideration and preferably robust automated regression test suites to migrate effectively. So we know now that Python 2.7 was actually just released as a service to those that weren't able to upgrade directly. Like, it was always the intention that everyone should go to Python 3. And if possible, we probably shouldn't have been building new projects on 2.7, but there were reasons. I had my reasons and everyone had their reasons. And if we then go to the present, so in January this year, Python 2 was sunset, meaning that it is now at the end of life. So in the document on this sunset initiative on Python.org, one could read, if people find catastrophic security problems in Python 2 or in software written in Python 2, then most volunteers will not help fix them. Fewer and fewer volunteers will be able to help you. You will lose chances to use good tools because they will only run on Python 3. I think this software written in Python 2 is a very important thing here. So Python 2 will probably always get security, maybe not always, but maybe for 10 years or something, get security patches. But our problem is going to be that all the libraries are very soon, I think, even going to not support Python 2. That is at least the risk you run if you don't upgrade. So a little bit about how one can go about porting. Your favorite library now actually does probably support Python 3. It's possible that it doesn't, but I would bet on it. They had 12 years to prepare it, so it might seem obvious, but some of these didn't support Python 3 until very recently, though. And a very large libraries, and I believe in particular many of the scientific libraries didn't do that. Well, I don't know if it in particular did that, but I remember some scientific libraries that didn't do that. So for you, the developer, the problem should now generally just be updating your requirements and your code, because the requirements should now be supporting Python 3. It's not necessarily true, but this is easier said than done, especially like updating requirements can be very tricky, especially if you have a ton of requirements and need to upgrade all components at once. That can be tricky. And you actually might have to do that in many steps, to just upgrade one requirement first, see what breaks, take the next requirement, and do some analysis of actually what depends on what in your code base. I actually did this recently for a large project. So we are building a limb system here at Sniperseek. It's in development now, but it's built on a project that is written in Python 2, which means, of course, that we have to take the negatives with it. We got a lot of features from it, but we also have to live with that it's actually in Python 2. But it is written in rather well in terms of compatibility with Python 3, but it doesn't. The tests do not run right away with Python 3. But I have now fixed that. We have a few tests that are not working, but it seems fine now, because I know what to do in those cases. And I'd just like to say that porting legacy code can definitely be a challenge. And you should expect that you need to be patient, and also that you will have to handle a lot of complexity, maybe a little bit more complexity than you used to. This depends very much on the project that you're working on, but this is not similar to the work that people generally do as developers, because this is so much larger in scope. But there are many tools to help and some strategies. So if I go through a few of them that just come to mind after my work on this. So first of all, you could not port. That is always a possibility, because you could run two interpreters at the same time, like one that is Python 3 with all the new code, and then just a tiny little piece of the code that's running Python 2. I'm just messing this as an option, and then communicate via HTTP or IPC or something. But I would personally not do this unless this is something that you expect to be very expensive. Like porting will be very expensive, then you might want to do something like this. But branching is one thing that I would recommend that people try out. That's at least what I'm doing. So my upgrade policy actually in this case, or like roadmap, is that I'm first gonna upgrade to Python 3.5, because that's the version that my version of Django has, and then we're gonna upgrade to 3.6, and then upgrade Django to another version at the same time, not at the same time, but one after another, and so on. So I think it makes sense to branch. So take away the thing that you're currently going to work on, let's say Python 3.5, and then, or maybe Python 3.8 directly, then get your tests working on that branch. But you have to, of course, merge regularly from master, because otherwise you will definitely have some code that you might just need to, or it's not definite, but it's not unlikely that you will just have to throw away your changes because it becomes too complex. If you have it living like this for half a year or something and don't merge from master. But all of this depends on the type of project that you have. The absolute, maybe most important rule is just to make sure that you have tests. This is particularly true in a dynamic language like Python, because in a static type language, you would at least know if everything compiles. And also most of the things that you would do to upgrade would probably be done by tools anyways. So this would, I think, be a non-issue in a statically typed language. So this is one of the negatives that you get with dynamically typed language. Of course, it's great to have it dynamic, but you get the downsides also, that tool support is just much worse, and that's an unsolvable problem, I believe. Yeah, so you could consider making the code support both versions of Python, at least at the beginning of the process. For this, there are many tools. For example, it's probably you know about all of these, but for example, you can import from Future, you can import different kind of behavior into the source file. And this depends on the very strong metaprogramming features that Python has, where like metaprogramming meaning that it's programming that actually changes your program, like it's programming your program. So if you, for example, you import from Future the print function, then the statement print isn't a statement anymore in the language. It's now a print function. So with this, you can change your source code to behave like it's like it would in Python 3, and thus it will work in both versions. You can also import 6, which is a similar thing. It's a library that has, it's named 6 because it's 2 times 3 is 6, I believe. And it's a library that's just focused on this, like converting between 2 and 3 by providing types and functions that you can use instead of the Python 2 features, so that your program will now work in both Python 2 and 3. So recipes for this, I can highly recommend, can be read at pythonfuture.org. But you can also just run a linter, maybe regularly on your build server, and just check, do I have compatibility issues or not? So that I would definitely recommend doing. But you could also, so these tools were like if you're going to support both versions at the same time, but you could also decide, no, now we're just going to go for Python 3. Enough is enough, which I think is a valid strategy today, even if you have a library, because we have sunset Python 2. And it makes sense at this point, I think, to say, okay, now we are also just going to support Python 3 and sunset Python 2. So if you use this tool, you get automatic conversion of your whole code base, or selected areas of it if you need. But in general, the idea is that you can either run it without any arguments, and then it converts the entire code base to use all the new Python 3 features. But you can also run it one rule at a time. And I would recommend doing that, at least if you have a large project. So what I've done is I run the tool with just one rule, see everything change, see if my tests are still working or have started to work, if they weren't working, or like how many of them can now run. And then I go for the next rule. And I always commit in between. So I have like the first rule is just about the future statement, like removing that. The next one is just about the print function, and so on. This will make it much easier to deal with issues that come up with this. Like rather than having this huge thing that just changed everything, it will also be almost impossible to review. I would actually, like at least in our code base, it would not be a manageable task to review. Of course, you can say, okay, I'm not going to review it, but the thing is that two to three may make mistakes, and you have to do manual changes also. So it makes sense to have commits that you can actually say, yeah, okay, this was totally automatic, and then I did these manual things directly after that. So at least the reviewer can review the manual changes. Yeah, like I said, this breaks compatibility with Python 2. So in this case, you're just going for Python 3. And another warning, you may want to know that linters, they can give bad advice. So for example, our linter is always telling us to, that's flake 8, that's always telling us to use when we're using the string type in Python 2, it's telling us to use 6.binary type. That's generally a bad advice, at least generally in text-based software. So in binary, like if you're doing image processing, for example, that would probably be what you're actually looking for. But at least it's not unlikely that you were actually thinking of it as a binary string. And also if you're hashing, the hash libraries, they require a binary string or a binary list. But in this case, the better advice is actually to use the text type, 6.text type. So just be aware of this. So this is one of the reasons for why I would break down my porting into detailed commits, because okay, first you run the thing and it did something silly like this, and then you can say, okay, that's still like the automatic change, and then come my changes with where I'm actually fixing those. This may help with porting, I believe. Yeah, also, not only the linters will give you bad advice, but 2 to 3 may also convert incorrectly. Like I saw some blatantly incorrect conversions that 2 to 3 made. This, I believe, also is because Python is dynamic. There is only that much that the tools can know about your code. Other things they will have to assume. It will just make a best guess. And it's the same as happens when you're using PyCharm, for example. It will sometimes point you to when you go to definition, it will point you to an incorrect position because it doesn't know for real in all cases what it is. That's because the language is dynamic and can do things that statically typed languages just can't. So now to the thing that I promised to reply at the beginning, what's the weight? So at least Unicode is much simpler now in 3+. You basically don't have to think about it now, is my feeling at least, when I've used Python 3. The language is now much more consistent. So for example, all classes are now new style. And if you didn't know about old style classes, then now you don't need to. And that's a good thing because they are basically an old legacy. So old style classes behave differently in some aspects. For example, the inheritance mechanism is not the same in old style classes and new style classes. The classes that you have been using might have been old style and might have been new style. This depends on if you were inheriting from object or not. So if all the classes in your project inherit in the end from object, they are new style classes. If they don't, they are old style classes if you're in Python 2. But if you're in Python 3, they're always new style classes. And they've just removed this concept of this old type of thing, which is very good because this complicates a lot of the responses that you get, for example, on Stack Overflow. People are always telling you, yeah, you have to think about this, it's an old style class, and this is a new style class, and so on. And it's confusing and can lead to subtle bugs. Now we have print as just a function. That's maybe not a huge thing, but I think that kind of thinking makes sense. Like print probably should never have been a statement. Like it's at least a little bit surprising that it's a statement if you come from C# and Java. Like usually just have a function there, and then you can like assign your print statements to something else, for example. So if print is just a function, you can say, because you're in a dynamic language, you can now say that print is actually something else. I believe actually there were ways to do that in Python 2 also, but they were maybe a little bit more advanced. So now if you expect an iterator, you will generally get an iterator. So that's a very important thing. You don't have to use X range, for example, now instead of range. You might have seen this in code, and maybe you just always knew to use X range and not range, but I think a lot of people might not be aware of this. That, for example, in this case, this piece of code behaves very differently in Python 2 and 3 in such a way that it will actually possibly break the code, break the program. Like it will lead to an out of memory exception in some cases. It depends on how much memory you have. But what we're doing here in Python 2 is actually to create like a huge list of, I think, 100 billion integers or something like that. And then you're like running through that. And that makes no sense because this is the idiomatic way of looping in Python. It actually, it's a very strange thing that it doesn't do what it in Python 3 does, which is that the range there, it is just an iterator. So that means that you can think of it like an object that knows its state, and it knows that it's currently at, let's say, 10, and it knows what to do next. And in this case, the next thing to do is increment by 1. So this will take no memory, or just about no memory. At least it will take constant memory in Python 3, but in Python 2, it takes memory that's related to the input size for no reason. So half is a float in Python 3. This, I think, is important actually in a high-level language like Python. Python is very high level in my mind, and it's being used like a high-level language by, I guess, everyone, but in particular by the scientific community. And if you would ask someone out from the street that just has regular like math knowledge, like what is 1 divided by 2, they're always going to tell you 0.5. But in Python, it means 0. And there are optimization reasons for this. It has to do with that if you have 1 and 2, they can be interpreted like integers in, let's say, C. And if you divide them, they should still be integers, is the approach that C takes. And the reason is that they don't want to do type checking. They actually also might think that it's wrong, but in a high-level language, I think this is what you should expect. Now, if you divide 1 by 2 here, it actually does a type check and changes it to a float, or it has an underlying object that actually is both an integer or a float. I'm not sure of that actually, but at least 1 divided by 2 now returns a float, which makes it a little bit more consistent. We now got function annotations in Python 3 also. So this is something that people that do some JavaScript programming might know from TypeScript. And the idea is that JavaScript, for example, is a dynamically typed language which does not declare types. You can actually do that, but you don't have to do that. And like in TypeScript, though, like you can add type information on top of that. Like you can say, okay, now I have this class, which actually wasn't even a concept in JavaScript. It is now, but at that point when TypeScript was introduced, it wasn't. And they introduced a similar feature like this. So in Python, it works like this. So you have like a function signature like here, like you're going to compile something. There's a source file name and a mode. And you can add like these annotations. Those are just any object that come after a colon in the parameter list. So this, though, doesn't have any effect on the compiler, which I think is an ingenious way of solving it, like an ingenious way of doing this kind of thing. So what they've done is they allow you to annotate the parameter, but the compiler does only add this to the like AST, like the compiled output of the compiler. And then there are third-party languages, third-party tools that can do whatever with this metadata that you get out of this. So in this case, you get the idea here is that you have help information in a function. So if you have, let's say, a tool that's similar to like Click that's generating command line interface tools, you could generate a command line interface tool with this that actually has this string. Of course, you could also do this with comments above or under or something, and people often do that. But it may be nicer to read if you actually have it in the same line. So here you have the help information for this this parameter source. Here's maybe a little bit more obvious example where we have the haul method, and then we have this haulable thing. We're saying that the first argument to this function is a haulable. And then we're saying it returns a distance. But as I said, like this has no effect on the Python interpreter. It actually it's only adding metadata for third-party languages. So then you could, for example, have PyCharm or any linter or something like that, use this to check if the correct or expected types are actually returned. And of course, for code generation or whatever. Yeah, we also got an extended iterable unpacking. So we used to be able to do this. This is called unpacking in Python. So what we have here on the right side is 0 and 1 in a list, and then we unpack it into the variables A and B. And if we print out A and B, then we would get like the tuple 0, 1. So now you can do the same, but you can add like the *C, which is something that we know from it's similar to the unnamed parameters that you can add to function signatures. In this case, you get like this list coming after 0 and 1. So it will like be like a dumping ground for everything else in this list. And this even works if range is an iterator, like this. This code works exactly like written here. And you can do the same from the beginning of the list. So here I'm dumping everything before the last 2 items into A, and at the middle of the list also. And of course, you can do any other combination also, like where you have more variables than this. This can be, yeah, this is a little bit like, this is neat, at least for some algorithms that, for example, if you want to do algorithms that you would generally do in a list processing language like Lisp. But this can also just be convenient to do when you're hacking. So we now also have simpler inheritance syntax. So I can confess that I'm not generally that font of inheritance, like I think it's it often complicates programs. It is often good and sometimes bad. And that's maybe the reason for this, but I generally have to look up this syntax that we have in Python 2. So it's somehow non-intuitive for me, but I understand it now because it has to do with that Python has multiple inheritance. And that's why we need to do this, but we need to say like super and then name of the class that we are, and then also the instance of us, which is self. And then you have some other, you would do differently if you were calling the init function in some mixin, for example. But when you're just doing regular inheritance, which most of us would do, and it's probably better if you don't do multiple inheritance too much, at least, because it complicates things, I think. But it has its place, but it's also quite complicated often. Then it's better maybe to be able to just do this. This is what I also always thought that you could do, but for some reason they didn't allow you to do this, even if you have just very simple inheritance. But now in Python 3 you have. So another thing that I was always confused by that Python 2 didn't do, and I've done this many times incorrectly. So when you're doing generators, which is generally a good idea when you're working with lists to generate, like creating these things that generate an iterator rather than just always creating large lists, because this is going to optimize your software. So maybe you would have wanted in your function maybe to like yield another generator. This I did use endlessly in C#. So I had some iterable. I wanted to iterate, let's say, like in this example, I'm yielding from the first line here, from range of X and backwards down to 0. So I get 5, 4, 3, 2, 1, and 0. And then I get, or actually 1, and then 0, 1, 2, 3, 4. And that's this latter iterator here. So, or generator. So what you're doing, you're decoupling like two different ways, you're decoupling a more complex generator here into two other generators. This makes a lot of code much simpler. This is maybe not the best example though. And this is possible now because you have, if you notice like this yield from statement here, if you would only write yield range X 0 minus 1, you would actually yield the generator. So it would, if you skip the two froms, you would get two items, but they would be the range generators. So that's very confusing. Yeah, now you get built-in virtual enums. This is not a huge thing for us, maybe because we're using PyEnv or Conda or something. But I think for the community, this is an important thing, that you get virtual environments directly from the programming like environment. You just download Python, you already have it because it's such a great thing. It's a little bit less complicated then. There's definitely some value in async await, I believe. So I think many people think that you can't do asynchronous programming in Python because of this famous global interpreter lock, but you can actually do that. So when you do I/O, the global interpreter lock, which is a lock that is on the whole interpreter, is actually released. So when you, let's say you download some data from some website and then you want to parse that data, but when you are waiting for that data, you want to do some other things. You can absolutely do that in Python because it does release the thread, so you can go on, or at least release this lock, so you can go on another thread and do some other things, and that can be happening on another core also. So, but the problem though is that asynchronous programming is generally considered complex. I think best programmers out there would probably be confused by asynchronous programming more than they are by synchronous programming. And there's this wonderful concept that I actually believe was first implemented in C# of the and this might be wrong, but I remember it like that at least. If you take like the most used programming languages, they implement this first, I believe, and that's this pattern where you can say that a synchronous program is now asynchronous. So in this code sample here, we're doing hello world, and what you do, you say async I run this main function, and first it prints hello, then it awaits for a sleep. This means that it's actually releasing the thread. It's releasing the lock, so it can be doing all the things, and then it prints world. And you have to have this syntax async at the beginning of the function, and then you have await here. This is exactly the same syntax as in C# also. I'd also like to mention that even if it was implemented in C# first, it was from a research paper, like an old one. So it was definitely an old ID, but it's a beautiful ID. It makes programming much simpler in the asynchronous space. At least to me, I think it's not only me though, but to a tiny brain like me, this is definitely a good thing. Yeah, we also get object-oriented file system paths with this pathlib library. So I have often found it confusing, and I regularly need to read up on how I just iterate over files in a directory in Python. I think I'm getting the hang of it, but it takes much more time than it took in Java and C#. Because it was a little bit less consistent to me, at least. And one of the reasons maybe was that it wasn't object-oriented. At least that's one approach to making it simple. So here's an example of what you can do today. You can say P is a path, just this current directory. And then you can, for example, just iterate there on this path. This makes a lot of sense to me to think about the file system as objects. Even if I like functional programming, but I also think object-oriented programming has its place, and I think this is an excellent example of that. So yeah, etc., etc., etc. Because we have 7 minor versions of improvements. So like we have been basically waiting with this bridge version 2.7 for various reasons. There's no like, we all have our reasons, but when we were doing that, they were still going strong and added several minor versions to Python. Some of it was backported back to 2, but some of it was not. And I've gone over a few of those things. And I think it's excellent now that probably most of us will just leave this 2.7 story behind us, and we can continue using Python without that, and it I think will be a brighter future for this excellent language. So was it worth the wait? Yes, yeah, I do think so, but I also think we should have done it sooner. Finally, there's a little bit of a code example here. So here I assign listening to action, and now I can actually do this in Python. I can say thank you for action, and this will thank you for listening. So if there's any question or any comments, then I can try to respond to that. Or if you just want to discuss something.
Oh, we have a question from Phil.
Yeah.
Thank you very much, Steinar. It was a very good talk. I wish I'd heard it 3 months ago before I started porting stuff.
Right.
So Phil is writing, are there any Python 3 linters that you recommend?
Yeah, so there is actually like this, so I believe that the question is like checking if your code actually works in both Python 2 and 3. So we're just using Flake for that. I think there's Flake, AutoPep 8, and there's also black, but that only works in Python 3, but it works for both 2 and 3. So you can install that in a Python 3 environment and have it run there. But I believe that's a really strong one. I want to go and check that out soon.
Yeah. Thank you. And you mentioned that you've been working on the common limbs and porting that. I imagine that was quite a big of an undertaking.
Yeah.
So what would you say was the biggest challenge in that project?
I found it that is like in that case they were using a lot of like 6 and all of this that I mentioned.
Mm-hmm.
So it made things a little bit easier than it might have been. So, and they were always running this linter that checked for this. But I would say it's the complexity. It's just like that you have like all of these things that you need to keep in your mind at the same time. So I think it's good to, like, the most important thing I think is not to lose your work by not merging from the other branches, because it's so complex that when you try to get back into it, it might be too complex.
We have another question from Phil. He's asking, how does the built-in Pi environment work? I've not heard about this before.
Yeah, I just know that it exists, so I don't use it. So I actually use PyEnv, which I think is excellent because it gives you like all this. You can use whatever version of Python that you want to use. So I think it's nice when you're porting and stuff like that. But I just saw this at some point. I think it actually, I do think it works like virtual env, like the very popular virtual env, like the old one. I think it's similar to that.
Okay, see, Phil sent a link. To the Coffee and Code Slack. Says that adding non-types can really mess with type checkers. For example, MyPy.
Yeah. So you're saying
there were apparently lots of comments above that.
Yeah.
Cake pictures. Right. Okay.
I can check the Slack afterwards also.
Yeah, good. I think that's all the questions that there were.
Yeah.
But yeah, you're on Slack, I guess, and people can contact you there if they have further questions, maybe.
Sure. I would like that.
Okay. Right, so thank you very much. And yeah, I think that's all we have for this session. We have 2 more events scheduled before the summer, one in April and one in May. And the next time will be on April 23rd. That will probably also be a virtual one, but we'll see. So keep an eye on the Slack channel for any updates. It will also be great if you could all have a look at the Trello board and maybe vote on some of the topics that you find interesting. And then I'll try to find people who are willing to present those topics. Yeah, if you have any suggestions or comments regarding Coffee and Code or the format or topics, people who you think might want to present, feel free to just contact me directly, either on Slack or on email. Yeah, that's it for today. See you all next time.
Thanks. Bye-bye.